Good morning and welcome to the Mono Lake Public Workshop on California gulls and other migratory birds. We have lots of folks joining, and so we're just going to give the group another moment to enter the webinar, and then we'll get started probably in about 2 more minutes. Thanks so much. Good morning again. We have a full agenda, so I think we should get started. Welcome to the Mono Lake Public Workshop 2. Today we will focus on Mono Lake, California gulls and other migratory birds. My name is Erin Bender, and I will be your moderator today. I am a senior environmental scientist with the State Water Board's Division of Water Rights. We're scheduled for 3 hours with a mid-session break, so we're going to get going. Next slide, please. We have a packed agenda today with 6 world-renowned avian scientists. We will begin with some background and purpose for today's workshop. We will have a Q&A session after the first 3 presenters, take a break, and return for the other 3 presenters, followed by more Q&A. Next slide, please. So a little background. On March 17th, the board heard an information item on new and ongoing Mono Lake modeling efforts. During that item, the board directed staff to prepare for a hearing to determine whether Mono Basin water diversions should be modified to reach Mono Lake's legally mandated water management level, and to hold 1 or more staff workshops to gather information on the condition of Mono Basin's public trust resources and potential management options. This is the second workshop. Our first we held on June 4th, and that recording is available on our Mono Lake website. This directive is also included as immediate priority 2.8 in the board's 2026 strategic work plan. Next slide, please. So the purpose for today is all about facilitating information gathering, promoting transparency, and providing an opportunity for interested parties, technical experts, and the public to share relevant data and perspectives regarding current conditions in Mono Basin. We know there has been substantial research that's been conducted since the 1994 decision 1631 was adopted. Today is intended to be transparent and a public forum that can help set a common factual foundation to inform future decisions regarding a hearing. This is not the hearing in D 1631. This is simply a listen and learning opportunity. No decisions will be made today, and this is not a space for policy statements. Today is a place to ask questions about the science we are hearing. Next slide, please. So some logistics for today. Today's workshop is being recorded. That recording, along with presentations, will be posted on the board's Mono Basin website tomorrow. And you can see that web link provided here. As mentioned, we will have Q&A throughout today's workshop. However, we will also accept scientific questions about the information presented today through noon on July 2nd. Board staff will review all of the questions submitted, but we may not reply to each one. Also, I want to bring attention to the presenter's materials already available on the website. Next slide, please. So today we are accepting questions through the Zoom Q&A function. We will try to answer all the questions. We may consolidate or paraphrase similar questions. And for simple questions like requesting links or dates, we may just respond in writing through the Q&A function. Questions are encouraged. However, please consider waiting until the presenters have completed their remarks, as many questions may be addressed during the presentation. And also, it might be helpful to review the questions already in the queue and upvote any questions you would also like to hear addressed. And finally, as a reminder, please ask questions about the scientific information presented today. We will not be addressing policy questions or statements. Next slide, please. So as mentioned, our first workshop was held on June 4th, and it focused on Mono Lake's water quality and salinity, as well as the brine shrimp and the alkali flies that form the foundation of the lake's food web. Dr. John Milak and Dr. Dave Herbst shared insights from more than 40 years of research in the Mono Basin. They discussed periods of prolonged lake stratification, known as metamixis, and how those conditions influence salinity, water quality, and nutrient cycling within the lake. They also described the biological effects on Mono Lake's brine shrimp and alkali flies. Their research highlighted impacts on algal production, which is the primary food source for both species, as well as changes in habitat availability, reproduction, energy demands, and seasonal population dynamics. If you hadn't had a chance yet to watch that presentation, check it out on the website. So that discussion provides an important foundation for today's workshop because brine shrimp and alkali flies are the primary food source supporting the remarkable bird populations that depend on Mono Lake. With that context in mind, today's workshop will focus on the birds of Mono Lake and the ecological connections between lake conditions and avian populations. So with that, I'd like to introduce our first speaker. Blake Barbary is a senior ecologist with Point Blue Conservation Science, whose research focuses on migratory shorebird conservation, habitat use, and population responses to environmental change across the Pacific Flyway. He co-developed the Intermountain West Shorebird Survey, a regional monitoring program that identifies Mono Lake as one of the 9 critical sites supporting approximately 90% of shorebirds in the Intermountain West and provides essential data to guide shorebird conservation and management. Blake, thank you for your presentation today. Let's get started.
Great. Thank you so much, Erin, and thank you to the Water Board for hosting this informational workshop today and the opportunity to present science. And it's been collected in a landscape scale in some of the examples that I'll show today, and really think about Mono Lake's place in the broader hemispheric wetland network, talk a bit about the Intermountain West Shorebird Survey, a collective effort to learn more about population change across the Intermountain West, and then we'll talk a bit about Mono Lake and some of the data that we've been collecting there as well. Next slide. So first, what are migratory shorebirds? They're these long distance migrants in many cases that are taking advantage of shallow water habitats primarily across large landscapes. These habitats can be quite seasonal in many cases. So they've evolved to migrate, in some cases, hemispheric scale migrations to take advantage of these different seasonal resources. So they're really these indicators of broad wetland networks, regional wetland networks, and then also just local wetland health as well. Next slide. And we see here this map in the background showing the scale of conservation that's necessary across the hemisphere with the Pacific America Shorebird Conservation Strategy. And that purple section really juts inland in the US West. And that's really because the birds have evolved to take advantage of this dry landscape that has these closed basins and saline lakes that have been providing reliable resources for many thousands of years for these birds, particularly during migration when they're migrating through to breeding grounds to the north. Many of them also migrate to breed within this landscape. And in particular, in the late season and fall, when they're migrating southward and done breeding, they come to these places for highly abundant resources to molt and replace their feathers, replace their flight feathers in many cases as well. So we see exponential use during that portion of the year as well. Next slide, please. And really just recently, we've started to wrap our heads around with analytical approaches and big longer term data, population trends for most bird species. And this is an example here from the State of the Birds in 2025. This is now updated every year or two. And we see the scale of loss for birds across these many different taxa, and shorebirds coming out as some of the biggest losers over the last 40 or 50 years across North America in particular, with estimates of around a third of shorebirds lost over the last 40 years. And we see the different taxa and some of the areas that are most impacted by human use and changing climate over time, with these wetland specific birds looking for seasonal wetland habitats and some of the grassland birds as well. Next slide. And so these data, though, we have a good understanding at the continental level. Those data that went into that were really mostly collected along the eastern portion of North America for these long-term data sets. So about 15 years ago or so, this was really recognized, and people in the West came together to build a new network. Next slide, please. To monitor shorebirds, Pacific shorebirds along the Pacific Americas flyway. And Point Blue and many partners built out a network to understand changes on the wintering grounds, primarily along the coast, across 13 countries of the Pacific coast of the Americas. There's now a monitoring network that's been going since around 2010, 11, and 12. And just last year, this network produced the first longer-term population trends for more than 20 species across this Pacific coast. And what we found from 2012 to 2021 were the vast majority of species had a declining trend. So to the left of the red dotted line is a negative trend, to the right is a positive trend. And we've highlighted the species that are really reliant on Western Canada, US, and Mexico, and the Intermountain West in particular as well. And what we see with those species that we're highlighting in the red arrows are predominantly negative trends, some of those significantly negative, particularly the American avocet down low with an estimated loss of 10% per year over that time period. We do see a couple of increasing trends at the top and the bottom as well. For stilts and yellowlegs, these are species that have much longer legs, so they can access deeper waters, also reliant a little bit more on freshwater resources as well. Next slide, please. And now we're starting to gather this collective understanding of population change for these migratory birds that are really hard to monitor and at the scale that's necessary. And this has led to new conservation designations for many shorebirds. And so the take home here is really that now many of these shorebird species are on the map, and we have an idea and the scientific understanding to estimate population change. And with these long-term negative trends, we're starting to understand more of the winners and losers among the species. And that's really highlighted many of these species that are reliant on Mono Lake and the interior West as well, both at the state designation level and federal designation level as well. Next slide, please. So with these monitoring networks now in place on the Pacific coast and throughout the East, there was still a big gap in understanding and conservation work around shorebirds throughout the interior West. And this led Point Blue and Audubon and many partners across the West to build out a new research and monitoring program to understand population change across the interior West. And what we used was a foundation of work done by my predecessors at Point Blue, then PRBO, which was the Pacific Flyway Project, which was from 1989 to 1995. A very interesting point in time for the Eastern Sierras and Mono Lake in particular. And this was an effort to essentially understand the basic distribution and abundance of shorebirds across the West at that point. And what we set out to do was recreate that, compare results today to the counts and results that we were finding 30 years ago during both spring and fall migration. We're also estimating wetland change. Now we have the ability to track surface water and broad scale change in wetlands using remotely sensed data as well. So we're estimating change in wetland availability as well over time. Next slide. So what we found, this was initial analyses were led by a graduate student, Sharon Montesano at Utah State University, who's finishing up her thesis. And results are coming out. They're somewhat similar to the losses that we've seen in shorebirds for other programs, where we see in the Intermountain West over 37% decline across 120 sites in the last 30 years. And we're estimating even larger declines in spring, more than 53% decline across these sites during the spring period. And the red and the blue dots show the distribution of declining versus increasing trends, but you see predominantly red dots across this landscape. Next slide, please. When we start to think about how the birds are distributed across these sites, the saline lakes hold the vast majority of birds. Darren's point, over 90% of the shorebirds that we're counting are located within these saline systems. And we see some stability in the general distribution of numbers of birds at Great Salt Lake and the other sites accounting for about 60%. But the rest of that 40%, including Mono Lake and many of these other important saline lakes and freshwater wetland systems, there's been a lot of variability and change in the numbers of birds using those sites because we've seen a lot of change in the habitats within those places as well and the extent of wetlands. The red arrow there does point to Mono Lake in that darker green color, where it actually has seen some stability and relatively little change compared to other sites of similar size. Next slide. When we start to look at the population change seasonally within these key sites, on this slide, we can see quite a bit of difference among sites, first of all. And down at the bottom for Mono Lake, we can see estimated declines of over 75% in spring and a negative decline of around 10% in fall as well. We're a little bit surprised to see these declines at first. But when we start to think about and zoom out and look at some of the other sites, each one tells its own story, and then some of them have stories that are connected, potentially. We see up at top, Owens Lake, which was largely dry during the first survey period, and now today we see the response by migratory shorebirds using that system in large numbers compared to previous years. Next slide, please. So this slide is, I do apologize for a lot of the numbers up there, but the SWL column is the change in surface water estimated across these sites. And the count is the change in the number of birds. And the numbers up top are showing that we're actually seeing a fairly significant decline in the amount of water and wetlands across these key sites in particular. When we looked at the whole regional zoomed out level of all the sites, it was around a 17 or 18% decline in both seasons. But when we look at just the largest sites where the birds are particularly reliant on, we see over 41% decline in the amount of surface water available at these sites in fall, which is the most important season for them within these systems, and around a 20% decline in spring. We see Mono Lake in the red box there, and you can see the surface water actually with a positive increase there, a slight increase, which makes sense as we know the story about Mono Lake with slightly rising water levels since the past surveys. So that does make sense that it increased a little bit. But what stands out to me is the magnitude. You see orders of magnitude, one or more orders of magnitude greater in change in surface water levels at these other sites, just highlighting the variability that those sites have experienced over this last 30 years compared to Mono Lake. Next slide, please. So when we zoom out to think about our regional results, we see these long-term declines that more or less line up with some of the other estimates that have been coming out for migratory shorebird populations in other areas. So validating some of these efforts that there are broad-scale decline across many of these species. And within the interior West, this highlights the functional decline of this network, which has been shown in a few different avenues with Patrick Donnelly and some of his work with the Intermountain West joint venture and other waterbird species and how they're using this system as well with similar results. And a lot of this potentially were due to the unreliability of these resources from season to season and year to year when the migratory birds are coming through looking for and needing these resources at every season. But we did see return of shorebirds to sites that are wetted, and showing that when conservation actions and water management is strategic to potentially help wildlife and groundwater recharge, we see the birds returning and we see them finding these habitats. And the conservation networks are now in place to both monitor and understand change over time, but also bring the information and science down to the people managing and working on the ground as well. Next slide, please. And now dig in a little bit into Mono Lake, which is this really unique and linchpin site across this network. Next slide, please. And this is just a representation of the trend estimates that we showed earlier, but more of the raw data counts that we're seeing. We've added on the April 2026 spring count into this slide, and it lines up with previous spring counts, which were quite a bit lower than we found 30 years ago, as you can see on this slide. But the fall counts, more or less lining up with the previous counts and just less variability overall. So telling an interesting story, if we really start to think about it a little bit more, and next slide, please, we'll see the distribution of this is really driven by phalaropes. Ryan Carl is going to be talking a lot about phalaropes coming up soon. So we see the system dominated, the numbers dominated by phalaropes, and also the Collegius sandpipers, small probing birds we'll talk about a little bit more in a minute, and then large numbers of American avocets as well. And next slide, please. So when we take phalaropes out of the picture, because we know those numbers are really dominating the counts at Mono Lake, we can see quite a decline in the numbers of birds since 30 years ago overall. And you see that dominance a little bit more in spring versus fall in particular. And highlighting 2022 here in particular, because this was a very extreme drought year. And we know several of the key lakes and nodes across the interior West were dry and offline that year. And so we saw about double the number of non-phalarope shorebirds at Mono Lake during that August count in 2022. Next slide, please. When we look in particular at the Collegius sandpipers, again, we see significantly lower counts than previous years. Relatively few in spring, but again in fall, a relatively small number, but double the number in 2022 versus the other falls that we've seen as well. Next slide, please. When we look at American avocets, these birds that are actually reliant on the Intermountain West for breeding and in molting, and they really gather in these saline lakes in the late summer and fall to molt their feathers and stay for extended amounts of time. We again see much smaller counts, potentially validating some of the population declines that we've estimated on the wintering grounds. And again, more than double the number in 2022 compared to the other 3 fall counts that we've had so far in recent years. Next slide, please. We look at snowy plovers, which have been studied for many years around the Eastern Sierras and the interior West. And we're actually seeing fewer numbers at Mona Lake, which is surprising to us because we have this one species that we've estimated a significant increase in the last 30 years across the Intermountain West. Those counts primarily driven by the Salton Sea and Great Salt Lake, where the receding lake levels there have uncovered more playa, which we think probably has contributed to the increase in populations there. But here we're seeing fewer snowy plovers at Mona Lake, which is interesting. But again, in 2022, quite a bit higher count than other falls as well. Next slide, please. So when we think about the context of Mona Lake and these results, there's quite an interesting decline since 1989 that we've seen at Mona Lake, despite slightly increase in water, relative stable water over that time. And this stability is quite unique, which is unfortunate for the network, but fortunate for the birds that can use Mona Lake in any season. And we see potentially some of the declines at Mona Lake related to Owens Lake being back online. That node was not online during the previous surveys 30 years ago. So we do think in particular in the spring, which when we would anticipate the Owens Lake effect to be the strongest when migratory birds are migrating north across the east, up the eastern side of the Sierras. If Owens Lake is there, they're going to stop first. It's the wetland restoration and dust mitigation provides quite a bit of shallow water, which is especially attractive to migratory shorebirds. And so this node being online may in part explain some of these declines that we're seeing. That same effect may have been what we saw a little bit in 2022 in the fall when Goose Lake, Lake Abert, many of the smaller sites across the Intermountain West were largely dry that year. So those nodes were offline and we saw potentially higher numbers at Mona Lake as well, just highlighting the essential place that Mona Lake plays with its stability within the flyway. Next slide, please. And I'll wrap up really just by tying this back to the first workshop. I hope everyone can go back and watch that if you haven't, to understand why birds are coming here and have evolved to rely on Mona Lake for so many years. And that's the brine shrimp and the alkali flies and these avocets and phalaropes in particular are visual foragers. Avocets do also filter feed as well. And they're taking advantage of these highly abundant resources, particularly in the late summer. The sandpipers as well, though, they're eating the flies and the brine shrimp. They're also probing to get the nematodes in the soil. These sandpipers have bristly, hairy tongues. They can sloop up that biofilm diatomic algal goo that forms where some of the fresh water comes and mixes with these hypersaline mud and water around the shoreline. So these highly abundant resources have been providing for these birds for many years, and these shorebirds in particular show us the response and how when things change in other places, certain places become more or less important during change over time. So next slide. I'll go ahead and just wrap up by saying thank you to the many agencies and partners and many volunteers, hopefully here today, that have helped make our ability to understand population change and migratory shorebirds in particular possible, because it takes a massive conservation network for the kind of understanding that we now have today for some of these migratory birds. Great. Thanks again, Aaron and the Water Board.
Thank you, Blake, for that presentation. Our next speaker, Ryan Carl, is a science director at the conservation science nonprofit Oikonos Ecosystem Knowledge and an internationally recognized expert on Wilson's and red-necked phalaropes. With nearly 20 years of research experience, his work focuses on phalarope populations, habitat use, and migration at Mono Lake and across the Western Hemisphere, combining long-term monitoring and advanced tracking studies to inform conservation of these iconic migratory birds.
Thank
Thank you,
you,
Carl.
Aaron. Hmm. Thanks, Aaron. Thank you for the intro and for having us, for doing this workshop. Thanks to Blake for that great presentation. That's really laying a lot of the concepts and context for talking about phalaropes, which are also a kind of shorebird. And I just want to start by looking at this first picture here, and this has a takeaway that I want you to remember, which is phalaropes are fearsome predators of alkali flies, and they love to eat alkali flies. So here's one hunting alkali flies. You could go to the next slide. And I also just want to start, you can play the video with a video here to kind of let us appreciate this spectacle that sometimes occurs at Mono Lake, occurring less frequently these days, where we see these really massive numbers, 40, 50,000 Wilson's phalaropes that are doing this amazing behavior called murmuration, where they're zooming around, probably trying to avoid a falcon or another predator. And people can see this at Mono Lake, and it's really one of the premier wildlife spectacles that we see at Mono Lake that helps people connect with salt lakes as a system. Okay, here's a good one right there. This is cool. Yeah. So we can go to the next slide. And I want to acknowledge that much of the work I'll be talking about today came from the research of Dr. Joe Gell and Dr. Margaret Rubega, who worked on phalaropes in the 80s and 90s at Mono Lake. Next slide. So there's two kinds of phalaropes that come to Mono Lake. We have the Wilson's phalarope and the red-necked phalarope. The Wilson's phalarope shown here, it's breeding in the interior of North America, and then it is going to head south and stop at Mono Lake for a migratory stop. And this isn't just any stop, it's a really important essential gas station where they do something called staging that I'll talk about more. And they're going to go after this, using all this fuel they accumulate at Mono Lake and other lakes. They're going to fly thousands of miles, up to 5,000 miles down to the tip of South America, to the Andes, to very far away locations in South America. And that's why Mono Lake's so important for them. It's an essential gas station. So next slide. The other phalarope we have has a very different life history, except when they're at Mono Lake, they're overlapping with Wilson's, but they breed in the Arctic, the red-necked phalarope. They're going to use the oceans, the coasts for their migration, but some proportion of them are also going to use the interior saline lakes and Mono Lake for their migration. They're also going to stop and feed at Mono Lake, and then they're going to head south to actually the ocean off of South America, off of Ecuador and Peru. Next slide. And I just want to really emphasize that the Wilson's phalarope is a really unique animal because it's the only one that is migrating between North America and South America and specializing on salt lakes. No other animal does this. And that means that they connect in a really meaningful way this network of salt lakes across the Americas. And Mono Lake is an essential part of that network. That includes, major lakes all the way down in South America that also are relied on by these birds. Next slide. Focusing in on Mono Lake, it is a key migratory staging stop for phalaropes. I'll talk a little more about staging, but what that basically means is they're stopping for a longer period of time. They're going to stop for 6 weeks or so at Mono Lake. In the case of the Wilsons, they're going to double their body weight from about the weight of one AA battery to two AA batteries. And they're going to grow almost a completely new set of feathers in just about 6 weeks. So this is an amazing anatomical and physiological feat. After that, they're going to do this insane migration, flying thousands of miles down to South America very rapidly, using all this energy that they gained at Mono. Next slide. So staging versus stopping, I want to really emphasize Mono Lake is a staging site for these birds, not just a stop. It's not just any old stop. So staging sites, when we talk about that, that means these are sites that have really, really abundant food resources that are really reliable. So on a migration, you know you can stop there and find all the food you need. And the birds refuel, they basically just eat nonstop while they're there, and they build fat for migration. They grow all those new feathers. And often at a staging site, you get really big concentrations of the population at that site of like the entire world population of a species or a big proportion of it. Next slide. The reason that Mono Lake is a staging site for phalaropes is primarily because of alkali flies. Wilson's phalaropes also will eat some shrimp, but when we look at diet studies across Mono Lake and other sites, we see alkali flies are what phalaropes are all about. They love eating alkali flies. When you take one alkali fly bite, you get a lot more nutritional content than when you eat one shrimp if you're a phalarope. And redneck phalaropes eat almost exclusively alkali fly larvae, and actually in experiments, they start to starve to death if you only feed them shrimp. And they're like, where's the flies? Oh, we're going to die because we're only eating shrimp in those captivity experiments. Next slide. So you get these really big aggregations of phalaropes at Mono Lake, like in this photo, because of those fly resources that I just described. And only large saline lakes can provide this kind of food. So we have Great Salt Lake, Mono Lake, other large saline lakes. There's not that many large saline lakes. We have Mono Lake, we have Great Salt Lake, we have Lake Abert in Oregon. Those are kind of the trifecta of phalarope staging sites that can host more than half of the world population each year during this short 6-week window, and it can host 90% of the adults because the juveniles tend to do something slightly different, but the adults really focus and do the staging at these sites. Next slide. I'm going to keep emphasizing this. Large saline lakes have lots of alkali flies for phalarope food, and I want to just harken back to the previous workshop where we talked about flies. And Dave Herbst gave a great talk that focused on the salinity levels and the submerged tufa rocks is what causes flies, fly abundance and phalarope food. So next slide. This is from Dr. Herbst's presentation, and this is showing us the amount of submerged tufa relative to the lake level of Mono Lake. And submerged tufa is really important for flies because they live out their reproductive cycle on it. So you tend to have more flies around areas with tufa rocks that are submerged underwater, and that is maximized, Dave said, at 6385 to 6390 lake level in terms of how much tufa is underwater. Next slide. And then Dr. Herbst also emphasized that salinity is even more so than tufa submergence is the most important factor for the production of alkali flies at Mono Lake. And this figure is showing his experiments at different salinity levels and how many flies were emerging, how fat they got. And these are actually based on his results, this figure here. Basically, the takeaway was if you get to higher elevations, you have greater fly survival, greater reproduction success, greater growth, and greater nutritional content. So if you're a phalarope eating a fly, you'll get more calories if the water is fresher and they're happier. And that's maximized at around 50% salinity, which is achieved at a 6415 lake level at Mono Lake. Next slide. So getting at our questions being addressed as the water board thinks about things, I wanted to focus on what has changed and what hasn't changed since the 1994 water board decision. What has not changed is that Mono Lake is still a critical stop for Wilson's phalarope populations. Also for rednecks, we just know slightly less about them because they also use other pathways during migration. Mono Lake is in the top 3 sites in terms of the highest abundances of migratory phalaropes. And many thousands of Wilsons and redneck phalaropes are still using Mono Lake each year in the present day. Next slide. What has changed with phalaropes in Mono Lake since 1994, we've detected some population declines in Wilson's phalaropes overall and at Mono Lake. Other key saline lake sites are being threatened with ecosystem collapse, which is increasing Mono's importance, which is similar to what Blake was talking about with this network is increasingly less resilient, but Mono Lake is a stable, bright spot for the phalaropes. And Wilson's phalaropes are under consideration for listing as threatened under the U.S. Endangered Species Act currently. Next slide. So the research I've been leading involves coordinating people at 6 of the key staging sites that really should account for most of the populations of these phalaropes in this region. And I just want to highlight Lake Ebert, Great Salt Lake, and Mono Lake on this map so you can see their locations. Lake Ebert is in Oregon. And we coordinate the timing of the surveys of a series of surveys each year at these sites since 2019. Next slide. Oh, and I wanted to acknowledge all of the many people whose work went into to collecting the data at all of these sites. Next slide. Yeah, Mono Lake in particular, where I have been working, we do a series of point counts that are standardized locations and where we go across the whole lake, but we count in specific locations. And this is looking at data from a series of surveys in 2020, if you're wondering what the phalaropes were doing during the pandemic. So when we look at these, we see bigger dots that show where the phalaropes were, and just want to point out that they're not evenly distributed. They're actually distributed over places that have more submerged tufa, usually, is where we see more phalaropes. Just to give you a sense that we're not counting the entire lake, we're just counting within these circles, but that we do cover the whole area of the lake as we're doing our survey. Next slide. We're going to look here at some historical data from Dr. Gell. The top graph there shows the number of Wilson's phalaropes in the 80s and 90s at Mono Lake. Just want to point out that we often had 50,000 or so Wilson's phalaropes at Mono Lake in the 80s. 30 or 40,000 was pretty normal in the 90s. If you drop down to the third figure there, Great Salt Lake, you'll see that the axis is in hundreds of thousands and that there's often 400 to 600,000 Wilson's phalaropes at Great Salt Lake during that time. Next slide. Here we're zooming ahead in the future, looking at our current 2019 to 2025 results. And again, the axis there is hundreds of, or 50,000 increments, and we see that there are often 200, 300,000 Wilson's phalaropes at Mono or at Great Salt Lake. And then if you look at the purple and orange dots, you see Lake Ebert and Mono Lake. And the important thing is, if you go to the next slide, I'd like to emphasize that if you take out Great Salt Lake is far away more phalaropes than other sites, but if you take out Great Salt Lake and look closer, you see that Lake Ebert and Mono Lake do stand out as being number 2 and 3 and sometimes swapping places in terms of their importance for Wilson's phalarope numbers. Next slide. And actually, I wanted to point out too that they seem to have maybe an inverse relation sometimes. Blake pointed out that Lake Ebert went dry 2021, 2022, and we actually saw our biggest contemporary count of Wilson's phalaropes. That was sort of rivaling the historic ones in 2021 when Lake Ebert was dry, and it might have been because the birds came down from Lake Ebert to Mono Lake. Next slide. So here we're looking at all of the data that exists about phalaropes at Mono Lake, essentially, in terms of phalarope population total estimates. Let's focus on the purple line first, which is my surveys, the contemporary ones. And I just want to point out a couple things. One is that we have not seen like a major declining trend that is the population crashing, getting lower in the current day. But if you look, we only have that 1 year where we saw numbers rivaling historic numbers. If you look at the blue line, that's Dr. Gell's work. We saw high numbers in the 80s. That really dropped in the 90s. And I'm not clear if that recovered. In the meantime, we don't have data, but I just want to also emphasize that these two counts have different amounts of coverage and different methods, yet we do cover the whole lake, and we have not, when you see that video at the start of those really huge flocks, we tend to notice that, and we have only seen that in 1 year in contemporary times. Next slide. Here is the same kind of look at red-necked phalaropes at Mono Lake, all the different studies that have occurred. And interestingly, I just mentioned the comparability. When we look at the comparability of the purple line and the historic data, we actually have more red-necked phalaropes in recent years. So there's still questions about how comparable these things are, but we're getting a decline in Wilson's phalaropes and an increase in red-necked phalaropes, which is suggestive that maybe both, we don't know the magnitude for sure, but both trends are happening for real. Next slide. And it really helps to look at the big picture context when you're thinking about these things because, like we talked about, birds move around and they respond to different conditions. So if you look at the three big lakes that are most important to the phalaropes, Mono, Lake Ebert, Great Salt Lake, combined at all the data available for those, and you look at the decades, we also see about a 32% decline compared with the 1980s across those sites. And that's a fairly comparable comparison between the survey methods. Next slide. This is also consistent with the Smith et al. Study from U.S. Fish and Wildlife that found a 70% decline in Wilson's phalarope numbers looking across North America. But as Blake showed a figure from that showed that was mostly coverage in the eastern U.S. But nevertheless, similar trends that we're seeing: decline in the 80s, more stability recently. Next slide. And one more data point here is that for world population estimates, we only have two, but one was from 1986 from North America, 1.5 million Wilson's phalaropes. In 2020, we did a South American wide survey, a very big effort down there where we got 1 million phalaropes. Again, consistent with this idea that there's maybe a 30% decline in the total number. Next slide. I don't want to get too focused on the population though, because my takeaway there that I want you to remember is yes, decline since the 80s. No, they are not crashing currently. I'm not talking about rednecks so much because we have less data region wide to show for that. But what we're really worried about is habitat loss and the prospect of future population declines as these sites are currently crashing. So this is Lake Ebert, and as we mentioned, it went dry in 2022. Here's a striking image showing that. Saline lakes, because of water diversion and because of a drying climate, are one of the most threatened habitats on Earth in a general sense. Next slide. Here again is Lake Ebert, just showing you what it normally looks like. It's not an ephemeral lake. It's a perennial lake that's usually there. So it's unusual. If you look back at this figure of the surface area, it has not dried up since 1975, except it has dried up twice in the last 10 years or so. Something has changed and it is drying up more often. Phalaropes arrive at this desolate lake bed, and you can imagine they don't find habitat and they need to go somewhere else. Next slide. Great Salt Lake, which we have mentioned has far and away more phalaropes and other shorebirds than any of these other lakes, is also in a crisis. It in 2022 reached its all-time low record of water level. The volume had shrunk by more than half, and the salinity, importantly, got higher than the invertebrates could tolerate in 2022, spelling majorly bad news for alkali fly productivity, among other things. Next slide. So just like at Mono Lake, the submerged rocks are really important for the flies at Great Salt Lake. Here on the left, you can see the rocks are covered with fly pupa when they're submerged. And on the right, this was in 2022 when they got exposed. Those rocks don't have any fly pupa. The fly researchers tell us that there was really, really low numbers of flies at Great Salt Lake that year. We also saw a major dip of hundreds of thousands fewer Wilson's phalaropes at Great Salt Lake in 2022 than in any other year. Next. Just to reiterate, Great Salt Lake's importance, it can have 60% of the Wilson's phalarope world population, 90% of the adults at it just at once. They're really concentrated there. It rose because of our massive, extraordinarily rare winter snowpack in 2022-23. That gave us a little reprieve on time to figure out how to save Great Salt Lake, but currently the lake level is declining again toward those kind of crisis levels where things are getting really bad. Towards those 2022 levels is where it's declining to now. Next. Because of these imminent threats to the habitat, the Wilson's phalarope was proposed to be listed as threatened under the U.S. Endangered Species Act in 2024. I was one of the authors of that proposal. There's 5 criteria for listing a species under this act, and the phalarope aligned with 2 of them. One is the imminent loss of habitat across a major portion of its range that could cause it to become endangered in the foreseeable future, aka Great Salt Lake and Lake Ebert drying up, or the prospect of that happening. And 2, the lack of a regulatory mechanism to protect the species and its habitat I want to emphasize here that of all that network, that map I showed that has all these saline lakes that are really important for phalaropes throughout the northern and southern hemisphere, Mono Lake is the only one with a regulatory mechanism for addressing water diversions and the amounts of water that flows in and out. No other lake has that legal governance ability to adjust how much water is going in or out. Next. So this petition and proposal was met with a 90-day finding, which means that the U.S. Fish and Wildlife Service said yes, we accept this proposal as valid, and we're going to do a full review of whether the species should be listed. That's currently underway. And importantly, Mono Lake, Great Salt Lake, and Lake Avert were proposed as critical habitat in the original proposal, which would mean that if they are listed and accepted, the habitat would also be protected along with the species should that listing happen. Should U.S. Fish and Wildlife decide that they are going to propose critical habitat. Next. So in this conversation about listing a species as the phalarope really so endangered, this question can come up of are the staging sites really so important that the entire population could crash or be threatened with extinction because of loss of a staging site? And unfortunately, there's a really prescient example of this from China in the Australasian flyway that shorebirds use in the Yellow Sea mudflats. This picture illustrates how there's massive numbers of shorebirds using this site as a staging site. And in the background, you can see the development. They've lost massive amounts of habitat at this area in the last couple decades. Next slide. And people were seeing really major declines in shorebird numbers on this flyway. And after much study, many studies have shown now that these population declines in the species in these figures are linked to the loss of the staging sites. The shorebirds on the flyway that use those staging sites that have had such habitat loss are having major population crashes. The ones that don't use those sites are not having such big population crashes. So you can imagine this being a corollary for the Mono Lake situation with other salt lakes. And what happened there is that there was less and less habitat. The birds concentrated on more and more birds and fewer habitat, and there's just not enough food. So not everybody survives. Next slide. So to get to the crux of what the water board is asking us scientifically, would a lake level of 6392 benefit the ecological status of the phalaropes at Mono Lake? My answer is yes. That lake level would benefit the production of alkali flies, according to Dr. Herbst, and that would provide more food for phalaropes. Next slide. And then building on that, would accelerating the progress toward reaching that 6392 lake level benefit the status of phalaropes? My answer is yes, because other vitally important staging sites are in danger of collapse or really have already collapsed in some cases and have bounced back but may collapse again soon. And that leaves Mono Lake as the only reliable large staging site. And I just want to point out that Mono Lake's about 4 to 5% of the surface area of Great Salt Lake. You can imagine trying to take that 500 or 600,000 phalaropes present on Great Salt Lake and put them on Mono Lake, and that there would not be enough food for them. Next. So I'm wrapping up here, but I just want to point out I have the literature cited here. They're going to post the talk online. You can link to all of the different citations here. Next slide. More citations, and next slide. Just like to say thanks very much for having me. Happy to answer questions in the Q&A and happy to be contacted at that email address. Thank you so much.
Thank you, Brian. Great presentation. We have a slight change in the agenda. We're going to jump to Dr. Matt Ryder. Dr. Matt Ryder is the waterfowl director for the Mono Basin Waterfowl Habitat Restoration Program and a research director at Point Blue Conservation Science, with more than 25 years of experience studying migratory bird ecology, wetland management, and conservation across North America. His research focuses on waterfowl and shorebird population dynamics, habitat requirements, and the effects of environmental change, helping resource managers make science-based decisions to conserve critical habitats along the Pacific Flyway. Take it away, Matt.
Great. Thanks, Aaron. Thanks, everybody. Great to be here this morning. Good morning, all. before I kick this off, I want to make sure I definitely highlight my co-author, Debbie House. Debbie is the former waterfowl director at Mono Lake, and much of the work I'll show today is the result of her over 20 years of implementing a monitoring program for waterfowl at Mono Lake. So none of this work here would have been possible without her dedication over many years and collaboration on pulling this all together. So thanks to Debbie. Next slide, please. So just hopefully a quick overview by the end of this presentation. Hopefully you all understand the importance of Mono Lake for waterfowl populations and also get a sense of recent trends that we're seeing in the abundance of waterfowl at Mono Lake. Next slide, please. So often we're challenged with water diversions beginning back in the 1940s. We often don't have a lot of baseline data to understand, well, what did this system really look like before we began sort of changing the water regime there? And for waterfowl, we have this really interesting piece of information from an investigation done back in 1948. And Dombrowski conducted several surveys in the fall, so during the fall migration at Mono Lake for waterfowl. And sort of, if you read that document, what you see here is he estimated that there was anywhere from 175,000 to well over 1 million ducks on any given single day of observation that he made at Mono Lake. So he did 3 different surveys in that fall window. So sort of that gives us an initial sort of sense of, wow, okay, historically, a long time ago, almost 80 years ago, there were anywhere from, several hundred thousand to over 1 million ducks using Mono Lake during fall migration. Next slide, please. And then in 1994, Decision 1631 highlighted that waterfowl would be disproportionately impacted by lake level decline as compared to other species groups. And they also highlighted that even at the target lake level of 6392, that would not necessarily restore all the waterfowl habitat that would be needed. And so ultimately, a restoration plan was required. That was created in 1996, and then in Order 9805 in 1998, the restoration plan was approved. And as part of that restoration plan was the need to implement a monitoring program that could be used to then evaluate the results of those restoration efforts. So increased stream flows, rising lake levels, waterfowl habitat restoration. And so beginning in 2002, and there had been some monitoring before this, but really in 2002, a standardized monitoring program was implemented. And this was a program that was implemented basically every year since 2002 as a requirement in order to keep track of the waterfowl populations and to create a data set that would allow us to better understand how restoration and lake level changes and other habitat changes might in fact impact waterfowl populations. And so that standardized monitoring consisted of 3 summer ground counts at Mono Lake, and that was to really look at breeding populations of waterfowl in the basin, and then 6 fall aerial surveys of Mono Lake, as well as Bridgeport Reservoir and Crowley Lakes. And those additional surveys, in part, as both Blake and Ryan have highlighted, was to sort of put Mono Lake and populations there in context with the broader landscape. And I'll talk a little bit about that in a bit. And then there also was a requirement for annual photography at Mono Lake, Bridgeport, and Crowley to track habitat change. I won't be talking about that today. I'll mostly focus on the 3 summer counts and the fall aerial surveys. Next slide, please. So jumping right in, the fall surveys, the aerial surveys consisted, again, 6 times a year during the fall to try to capture the migration window. The surveys covered 15 shoreline segments, shown here in yellow, along with 8 cross-lake transects that were divided anywhere from 2 to 4 sub-transects. And on the left here, you can see some of the population, the count data over the time period from 2002 to 2023. And a couple things I want to highlight here. First of all, you can see that The orange bars and then the teal bars here represent two species, ruddy duck and northern shoveler. And I forgot to highlight this, but Dombrowski highlighted when he saw over 1 million ducks, he said, look, the most numerous were by far the northern shoveler and the ruddy duck. And so that's still consistent today, where they make up the majority of the waterfowl that we see during the fall surveys. The other thing I just wanted to highlight as well is that if you look at the tallest bar, that correlates with about 50,000 birds in total counted during the fall surveys. So that's 6 surveys resulting in a total of 50,000 ducks being counted. That is much lower than the hundreds of thousands to well over 1 million ducks that were observed by Dombrowski in 48. Granted, that was a single data point, but I will highlight that is a pretty big change if we think about that as a, sort of the 80-year change, if you will, in ducks in the basin. Next slide, please. I also will just highlight here, just keep an eye. You don't need to worry about the x-axis or the bottom, but the bars are what I want you to focus on, and just highlight that the ducks are really concentrated into several important areas. In the segments, the graph on the left, those are those shoreline segments. They're really concentrated in an area called Wilson Creek in the northwest corner of the lake, as well as several other locations that are kind of close to Wilson Creek or over in the southeast corner of the lake near South Shore Lagoons and Salmon Springs. And then on the Cross Lake transects, they're really concentrated on 2 transects in the northern part of the lake, transects 7 and 8 on these surveys. And those actually also correlate too with the data that Ryan just showed on phalarope. So really waterfowl concentrating in that sort of northern portion of the lake during the fall migration. Next slide, please. So what have we learned over this time series? Well, this is just a plot of the bird abundance on the y-axis and year on the x-axis. And in orange or yellow-orange is sort of the trend in all waterfowl. And then because northern shoveler and ruddy duck makes up such a large proportion of the birds, I've highlighted those here in blue for the northern shoveler and green in the ruddy duck. And those 2 species are also experiencing significant declines in this time series since 2002. So that's certainly something that's now is occurring over the last 20 plus years. Next slide. So landscape context, as we highlighted, is pretty important. So we wanted to compare what's happening at Mono Lake to what's happening at the nearby Bridgeport Reservoir and Crowley Lake. And if you look at what I want to focus your attention on, the blue line, that's the trend on the left in ruddy duck and on the right in northern shoveler at Mono Lake. And then the red and green lines are the trend lines for Crowley and Bridgeport. And what you will see for on the left slide with ruddy duck, while they are decreasing at Mono Lake, populations of ruddy duck over the same time period have been increasing at Bridgeport and Crowley. And for northern shoveler on the right, they have been decreasing at Mono Lake, yet increasing quite significantly at Crowley Lake, but also decreasing at Bridgeport Reservoir. So I'll get to this in my conclusions, but certainly for ruddy duck, this highlights that that decline is somewhat isolated in that population at Mono Lake and may help us point to maybe something at Mono Lake is changing that's actually causing this decline, as opposed to a more broad scale decline in ruddy ducks. Next slide, please. Just to tie back, folks have been talking about the importance of brine shrimp and alkali flies. We were able to work with our colleagues at UC Santa Barbara and Dr. John Milak to use biomass data on Artemia from their limnology surveys and look at how that relates to the abundance of fall waterfowl, and particularly northern shoveler and ruddy duck. And what you can see here is a positive and significant relationship between the abundance, the biomass of Artemia, and the abundance of northern shoveler and ruddy duck. So essentially, more brine shrimp in a given year ultimately results in more waterfowl being counted. Next slide, please. Now moving on to the summer breeding surveys. So these are aimed to capture both the number of adults breeding at Mono Lake as well as indexes of productivity, so the number of broods and ducklings. These are 3 ground surveys per year, and they cover 9 of the 15 shoreline segments or units that are typically covered in the fall surveys, and those are shown here with the red dots. Next slide, please. So again, interestingly, with the breeding ducks, two, three, two species of duck, one goose species really have dominated the counts over the 2002 to 2023 window, with gadwall by far being the most numerous species, along with Canada goose and mallard. These are, again, the adult counts. And you can see the similar sort of stacked bar graph on the right, showing the time series, and the purple being gadwall, the yellow being mallard, and the red being Canada goose. So again, really a system dominated in many respects by 2 duck species and a goose species. Next slide, please. The distribution, they do tend to aggregate in several of, 4 or 5 of the 9 units seem to really have most of certainly the adult breeding adults. Um, those are spread around the lake with some of the units, again, Wilson Creek in the northwest, as well as Mill Creek in the northwest, and then places like Salmon Springs out in the southeast part of the lake or eastern edge of the lake. So similar in some respects, a similar distribution, at least for the shoreline segments, as to the fall migration distribution. But maybe a little more spread out with and less concentrated when we're talking about the breeding season. Next slide, please. So similarly, we looked at trends and for the breeding birds, we have the ability to look at trends in both the adults as well as in the number of broods that are counted each year, and then ultimately the number of ducklings that are indexed or counted each year. And what you can see here was something interesting and a little surprising for us as we began to look at this data set, in that the adults, and particularly mallard and gadwall, are showing a significant decline in this time series over this 22-year period. However, the number of broods and the number of ducklings, so a measure of actual productivity occurring at the lake, were relatively stable. This is not something we currently understand why this is occurring, and is really hopefully going to be a focus of some future research to really tease out why are we seeing declines in the adults occurring, the likely breeding adults, but yet stable productivity numbers. Next slide, please. Now, looking at a landscape context again to try to understand, are the declines we're seeing in gadwall and mallard, those 2 most abundant species, isolated to Mono Lake, or are they part of a more widespread pattern of decline in these species? We see kind of 2 different results. And so we didn't have those nearby surveys of Bridgeport and Crowley for the breeding ground surveys. So we took advantage of eBird status and trends data, as well as California Department of Fish and Wildlife surveys to get estimates of trends in breeding birds for other places in the flyway. And at the top row, you can see Mono Lake. That's the estimates from the analysis I just showed, where both gadwall and mallard are significantly declining. However, when we look at gadwall, those estimates in green are from different states, as well as show highlight, and from the eBird status and trends data show actually significant increases in gadwall over the same similar period of time. So this suggests that the decline at Mono Lake is somewhat unique and may be the result of something changing at Mono Lake and having an impact on gadwall. Alternatively, mallards decline at Mono Lake appear to be part of a broader decline in mallard populations across the Pacific Flyway. And so more research is needed to understand and sort of tease apart these changes, but certainly gives us some evidence that some focal research is needed, particularly maybe on gadwall, as to why potentially their populations are declining at Mono Lake while they're increasing in other parts of the flyway. Next slide, please. I now just want to show a quick analysis that we've been working on, trying to link lake level and breeding habitat for waterfowl at Mono Lake, and then ultimately with populations of breeding ducks. So as lake level changes, we ultimately end up with different amounts of shoreline and lake fringing wetlands. And one way we can index sort of that change, that year to year variability, is using satellite data, remote sensing data. And so we used what we call the Normalized Difference Water Index, NDWI, which gives us sort of a measure of how wet, how much wetland is in those units in the surrounding the lake. And what you can see here is in the left, as lake level increases, we get a steady increase in NDWI, sort of this sort of index of habitat quality. And we think higher NDWI means better habitat. And on the right, which you can see and sort of validates some of that, is the modeled association between NDWI amount and the total number of breeding waterfowl. And you can see a significant positive relationship. So as we have higher NDWI, ultimately as a result, as higher lake levels, we see higher numbers of breeding waterfowl. Next slide, please. And again, these are not necessarily cause and effect analyses. These are not experimental. These are observational design. So these are associations. As someone always says, correlation doesn't necessarily mean causation. But again, you can see these plots again, the decline in adult breeders through the time series that we have, and then the pattern of NDWI over that same time period. So again, as we're seeing over time, seeing declines in breeders, it's related to the measure of NDWI and lake level, and we're seeing a decline in NDWI over that same time series. Next slide, please. So just to sort of summarize and wrap up, Mono Lake waterfowl historically numbered in the hundreds of thousands to millions potentially, but those numbers have declined since 1948. The ongoing data collection at Mono Lake has been incredibly important for us now to begin to understand population dynamics of the breeding and migratory waterfowl using the lake. We're also able to start now understanding what's driving some of those changes. Certainly evidence of declining use of the lake for most of the most abundant species, migrating ruddy duck and northern shoveler, as well as breeding gadwall and mallard, despite the fact that productivity appears stable, at least for breeding birds. Declines in gadwall and ruddy duck in particular appear to be unique to Mono Lake when we're comparing them to broader trends. Perhaps the declines in mallard and northern shoveler are a little murkier or maybe tied to broader changes in the system, but certainly more research is needed there. Changes in the fall brine shrimp or Artemia biomass is tied with the abundance of northern shoveler and ruddy duck, which we know forage on that food resource, as do the shorebirds and other species using the lake. And changes in lake fringing wetlands is significantly tied to the abundance of breeding waterfowl and lake levels. So ultimately, higher lake levels lead to more wetland habitat and more breeding ducks, at least from our initial analyses. And lastly, I'll just highlight, I think it's really important for us to begin to understand that difference between the breeding adults and productivity. Productivity is obviously hugely important when we think about sustaining populations. And so we really want to understand how we're seeing declining adults and that stable productivity. Next slide, please. And with that, I just want to thank everyone for your attention today and acknowledge Mono Lake Committee, California DFW, Caltrans, LA, DWP, the folks at Oikonos and UCSB for their collaboration, as well as California State Parks. Thanks.
Thank you, Matt. Another great presentation. We'll now open things up for questions. As an overview, Blake provided an overview of migratory shorebirds across the Pacific Flyway. Ryan presented research on red-necked and Wilson phalaropes, and Matt, the current waterfowl director of Mono Basin, as required by Decision 1631, shared research on waterfowl at Mono Lake. You are welcome to use the Q&A feature to drop your questions in there. We have a few questions to get us started. So we heard a lot today about the interconnectivity of the saline lakes. With the current environmental challenges at the Great Salt Lake habitat or Great Salt Lake habitat, can we expect more migrating birds to visit Mono Lake? And I'm not sure if this is for Blake or if you all want to jump in.
A great question. I think the response would likely be different for different species. And to Ryan's point in particular, phalaropes and avocets, some of these species that are especially reliant in very large numbers and large congregations in late summer and fall. Our landscape level surveys are showing some evidence of how they will redistribute when certain sites are on or offline, or maybe have less or more habitat available. So in the case that ecosystem was to fully collapse and the food web collapsed there, I think we would anticipate some levels of increase across Mono Lake and some of the other saline lakes in the Eastern Sierras and within the Southeast Oregon and Northeast California region, where there's some similar lakes where we've seen different increases and decreases based on the condition of some of the other key nodes in the system.
Ryan, you want to jump in on that?
Yeah, I just wanted to add, we do have a little bit of data showing some interesting things. Like I mentioned that when Lake Abert dried up, we had more birds at Mono Lake for phalaropes. When Great Salt Lake hit that early crisis point in 2022, we saw a decrease in about 150,000 or so Wilson's phalaropes that was not visible. We did not see visible rises at other places during that time. Basically, we saw a big decline and we couldn't say like, oh, well, we saw those birds go someplace else. So we're not quite sure what happened to those birds. We also have been doing phalarope tracking and trying to get at these questions of like, if a bird arrives at Great Salt Lake and it's dry, can they actually fly to Mono Lake, or is that something that they do? And we've seen basically no evidence yet. We have limited data that birds are transiting between Mono Lake and Great Salt Lake. We see them doing this like north-south kind of movement quite a bit, where they seem to head north-south. So like Lake Abert is straight north of Mono Lake. So there's a lot of big questions about how flexible they are to responding to these kind of perturbations. And we are just at the cusp of understanding that.
Thank you. Very interesting. Our next two questions are about phalaropes and their listing. So the first one is, under the current administration, what are the chances of phalaropes getting classified as endangered? And if there are proposed, or if any proposed changes to the Endangered Species Act regulations or designations of critical habitat were to possibly change, how might that affect a phalaropes listing?
For the first question, I'd say your guess is as good as mine as whether the political situation will result in a listing. But I will say, surprisingly, the advancement of the petition being accepted and going to a full proposal, that occurred under the Trump administration. Often these things also take many, many years. So there's really, I can't predict, when and how the decision will come down. In terms of the changes to the Endangered Species Act, based on my understanding of what the Trump administration is proposing, the main change that would affect this proposal would be that the phalarope is listed, or proposed to be listed, as threatened under the Endangered Species Act. There's a threatened listing and an endangered listing. And the threatened listings being proposed to be sort of watered down so that the threatened level would not automatically give the same protections as the endangered level, and it would be like a species-specific protection. There's some changes proposed for critical habitat too, that in my reading would probably not affect Mono Lake so much, because it's talking about whether the critical habitat is occupied or not occupied. In the case of the critical habitat proposed here, it's all occupied habitat that in my understanding would probably still be called critical habitat. So yeah, hard to say. Watering down, changing the Endangered Species Act or giving it less teeth certainly would be likely to affect, how it's implemented should they be accepted for the threatened status.
Okay, thank you for that. The next question is for Blake. Can you please speak to how the 2023 wet water year um, influenced the study period, considering that was in the middle of a recent study period, how that might have influenced results?
That's a great question. The Intermountain West Shorebird Survey, as we mentioned, we had the first widespread survey across the region in 2022, which was the end essentially of a pretty significant drought cycle across the West and in particular the interior West. And that was the big winter in California in late 2022 and early 2023, where snowpack returned and reservoirs filled back up. There was flooding across both sides of the Sierras. It definitely impacted the spring survey that next year, where we saw an interesting dichotomy that migratory shorebirds and many migratory waterbirds experience across these types of dry landscapes that can go into very extreme wet and extreme dry, where it flipped from one season to the next, where there was many dry places that were not available for shorebirds, which are really many of them are looking for very specific, water depths that can be found in different places in the landscape depending on the season. But first there has to be water, right? And that was what we saw in August 2022. Many of the lakes, in particular, the more shallow saline lakes had gone dry, like Gabert with just little water, and Goose Lake and a few others. But by the next spring, the birds were seeing too deep water in many places, flooding across the Lahontan Valley, and much higher high water levels, which also meant that most of those wetland habitats were not necessarily accessible to many of these shorebirds. So they can see too dry. They can also see too wet in many cases. So we had really low counts that spring. We also have seen, I think, a bit of a lag effect as well. When these sites go offline for many years in a row or several years in a row, most of these shorebirds are relatively short-lived. So it can potentially take generations for these birds to relearn and at the population level to re-inhabit some of these places that had been dry for some years before. So as this research and survey potentially continues over the next few years and we're able to track some more of that variability longer term, some of those ideas we anticipate will start to show up more, and we'll see maybe another really wet year, or as we're trending right now, potentially some, again, really dry years upcoming.
Thank you. Appreciate your answer. At this time, let's take a break. Let's look at a 15-minute break. So we'll be back at 10:40. And we'll reconvene with two more presentations and some more Q&A. So feel free to continue dropping questions in the Q&A, and we'll see you all back here at 10:40. Welcome back. Hopefully, everyone has been able to grab a fresh cup of coffee or tea and is ready for our second half. Before we get started, I do have one announcement. Unfortunately, Dr. Sean Boyd is unable to join us today. We're having some connection issues. So we'll try to post a recording of his presentation on our website in coming days, and we'll encourage you to check that out once it's available. Thank you to those that have dropped questions into the Q&A function. Let's keep them coming. And with that, let's introduce our next speaker. Ryan Burnett is the Sierra Nevada Group Director at Point Blue Conservation Science and a wildlife ecologist with more than 25 years of experience studying bird populations, habitat management, and conservation across California. He has led Point Blue's long-term California Goal monitoring program at Mono Lake, helping advance one of the longest-running bird research efforts in the Western United States and improving understanding of how Mono Lake conditions influence gull populations. Ryan, thanks for being here today.
Thank you, Erin, and thank you all for being here. I'm going to talk today about our California Goal study at Mono Lake, and more generally about the natural history of California gulls and the implications of Mono Lake management on the gull populations. I first wanted to start by mentioning some of the many people who've been involved in the California Goal project over the 43 years of its existence. That started out with folks like Doctors David Winkler and Joseph Gell, and many of my colleagues at Point Blue, including Dave Schufer, Justin Haidt, Christy Nelson, and my current collaborators, Dr. Annie Schmidt and Dr. Grant Ballard. I also want to mention our collaborations with the Mono Lake Committee, California State Parks, and the Inyo National Forest to make this project possible. So today I'm going to talk again about California gulls study we're doing at Mono Lake, provide you some background about California gulls and their natural history, and then some discussion about the context of California gull conservation in the Western U.S. Next slide. So California gulls are a pretty interesting bird. We often think of gulls that often get no love. They're thought of as kind of very similar looking between species, but California gulls are pretty unique. And in particular, there are two subspecies of California gull. There's a nominate species, which is the Californicus subspecies, which is the one we're talking about today, that breeds in these highly saline lakes in the Great Basin. They have unique adaptations that allow them to feed on brine shrimp and flies. They almost behave like phalaropes in ways by spinning, using their feet to kick up shrimp and flies to the surface. Really efficient foragers on these unique resources. They take 4 years to reach their breeding age, and they typically live about 20 years. Interesting, it's one of the few bird species that is named for a state, and it's the state bird of a different state. So they are the state bird of Utah, and the reason for that is they're famously credited with saving settlers' crops in 1848 by consuming katydid plague in Utah that saved their farms. Next slide. So the world breeding population estimates of California gulls vary. One good estimate or best estimate we have is there's maybe around 400,000 breeding birds, remembering they take 3 to 4 years to reach breeding age. So there's lots of other birds in the population. They're not part of the breeding population. Again, there's two subspecies, the Californicus subspecies, which is really breeds in the Great Basin. And then there's the prairie subspecies Albertensis, which breeds in the prairie potholes up into the Canadian lakes. And interestingly, the Albertensis subspecies primarily breeds in freshwater lakes and feeds is a piscivore. It feeds mostly on fish. So the California subspecies is quite unique in what it's feeding on with brine shrimps and flies in these alkaline habitats. The Mono Lake population, breeding population of California gulls as of 2025 was 21,000 birds. And our highest estimates about 30 years ago were 45,000 breeding birds. We'll talk more about those declines here in a minute. The Great Salt Lake area has the largest population, around 140,000 breeding birds, but a complete census of that population has not happened in many years. So that estimate may be off based on recent changes to the lake. And then Nathan will talk a few minutes after I'm done here with about the South San Francisco Bay population, which started with a small colony in the 1980s, and now is one of the largest colonies in the world with over 50,000 breeding birds. And I also wanted to mention there that of the 400,000 estimate of breeding California gulls in the world, it's split roughly evenly, we believe, between the two subspecies. Next slide. So at Mono Lake, California gulls primarily are using the islets that now occur behind Nedget, which is on the right-hand picture. But historically, they nested on, in the late 70s, they were nesting on Nedget Island, which is the large black volcanic island, and then also on Paoja Island, which is the large white island to the south there. And we'll talk more about why that has changed, but basically lake level declines resulted in coyote access to those islands, and they abandoned those islands and have since nested almost exclusively on the Nedget Islands, with small populations also on Paoja Islets. But the primary breeding islands are Little Tahiti and Twain. Those represent the vast majority of breeding population at Mono Lake. Next slide. All right, so our California gull study at Mono Lake, there were efforts done in the late 70s into the early 80s on California gulls, but the standardized project has basically been run the same way. Started in 1983, started by Dave Shuford, and has run through 2026. We will be out there in about 2 weeks to collect the data on how many nests or how many chicks they've produced. What that study is doing is looking at the total breeding population based on number of nests we find. We basically double the number of nests we found, knowing that it takes a pair to make a nest. And then we go back in July and we count the number of chicks that are present in a series of nest plots that have been standardized since 1983 to then come up with estimates of how many chicks have been produced per nest. These counts were historically ground-based until 2017. A crew of folks would go out onto the islands. They'd mark each and every nest. We're talking about, marking 20,000 nests. It was quite a bit of effort, quite disturbing to the gulls. Gulls can be opportunistic cannibals. And so in the late 2010s, Christy Nelson, who was running the project then, decided to experiment with doing fixed wing aircraft image capture to see if we could use that to monitor the populations with less disturbance. So for a series of 3 years, from 2017 through 2020 or 2019, the study was run both as a ground-based study and also capture of aerial imagery to ensure that the differences between those two could be calibrated to have consistency in data in the long-term study. In recent years, we've switched to using uncrewed aerial vehicles or drones to capture this imagery, safer than flying low fixed-wing aircraft and more efficient, and actually capturing higher resolution imagery. So for the last 6 years, we have used uncrewed aerial vehicles to capture the imagery. And you can see here on these slides a close-up image of gull nests on the ground, and then the stitched together imagery of Twain Islet there. Next slide. So California gulls nesting population at Mono Lake has been in pretty steep decline, in particular in recent years, in the last decade. On average, across the 43-year study, we've lost 353 nests per year. And that is a highly significant trend with a R-squared of 50, explaining 58% of the variation in gull decline is just year. And so the early 90s represented the highest gull population with a pretty steep decline, and then in particular the last decade, a strong decline. Next. So the number of chicks produced per year is more variable than the population estimate. And so you see these large swings in data. This is largely the result of poor productivity years on the lake. In particular, if you look at these, they coincide. These low dips or troughs in this data show periods of meromixis or lake stratification that resulted in low productivity. But I want to highlight in particular this last decade, where we haven't seen this. When the swings drop to the lower levels, those lower levels are becoming lower. and the peaks are much lower as well. And so we're not recovering back to those high, when we have good productivity years, they're not as good as they used to be. And when we have bad productivity years, they're worse. In fact, in 2022 and 2024, we had the two worst productivity years at Mono Lake, with 2024 representing almost a complete breeding failure, population breeding failure at Mono Lake. And so that's also a highly significant trend. And there is a strong decline of 553 fewer young California Gold young produced per year across the lake. Next slide. Can I get next slide? Thank you. So I wanted to review some of the other literature that's come out on California gulls studied at Mono Lake. In particular, a study from 2026, Reggie et al., looking at factors influencing the nesting population, so the number of adults nesting each year at Mono Lake. They studied this from 1987 to 2003 using our data set. They found 4 factors explained 80% of the variance in nesting gull numbers. Those things were the density of brine shrimp around egg laying period, which is a positive relationship. The mean temperature the month before egg laying, which is also positive. The gulls were doing more nesting when it was warmer weather, right before they started nesting. And then the number of potential 4-year-old gulls returning to breed for the first time. So looking back 4 years ago, how good was productivity was a factor. And then there was a relationship with the winter coastal conditions the previous fall. So the birds were coming back with better fitness. Next slide. So then we did a study in 2013 looking at the factors that might be influencing chick production. So the previous study was looking at how many gulls came back to nest each year. And then we wanted to look at, well, what's driving that variation in chick production. We had 2 variables that explained 46% of the variance in chicks produced per year per nest. Remember from those 2 slides I showed earlier, that chick production was far more variable, so harder to explain all that variance in a model. But we were able to explain almost half of the variance in chick production per year. The 2 factors we found most important to explain almost all of that variation were lake level increases the prior year, a negative relationship. So that means basically if there was a large freshwater input the year before, which often led to stratification of the lake, that would depress chick production. And then a positive relationship similar to the number of gulls nesting with that beginning of nesting season high temperatures. So warmer conditions at Mono Lake, better for producing chicks. Several other factors were in the model, in the final model, but they really explain little variance, and I probably won't go into those right now. Next slide. So just showing here the relationships, the partial dependency plots from that analysis. You can see that strong relationship with lake level change the previous year, and then the April, May average high temperatures. The relationship, once you consider lake level change the previous year with shrimp abundance, which is different than what Matt showed. Matt showed biomass, which I think is a better measure now. This was 13 years ago we did this analysis. It should show that there was actually a negative relationship, but it was very weak, explained very little variance, and actually wasn't statistically significant, but it was selected to stay in the model. Okay, next slide. So it's important to talk about not just factors influencing chick production, because there's another factor influencing the nesting population at Mono Lake. They are highly dependent on terrestrial predator-free nesting conditions. And so they need these islands to nest. And in fact, an early paper by Schuford and Ryan showing that nesting islands secure from predators and human disturbance are nesting gulls' greatest need at Mono Lake. Again, Nedget supported the majority of the gull nests until 1979. Maybe 2/3 of the population was on Nedget. A third of the population was on either Peoha or on the Nedget islets. But a land bridge connected Nedget to the mainland in the late 1970s. That resulted in coyotes being present on the islands. They raided the colonies in multiple years in the late 1970s until it was almost completely abandoned by the gulls. And that resulted in almost the entire population moving on to the much smaller area that is the Nedget islets, where they primarily occur to this date. They have not moved back in any significant numbers to their former breeding sites. Next slide. So terrestrial predators being the largest threat, again, 70% of the population was on Nedget Island, the large island there on the left, until coyotes accessed it in the late 1970s. Again, in 2016, with low lake levels again, we found evidence on both Nedget and Java. Java is the next island to the right there in the image. We found coyote scat on Nedget, and there was potential evidence but unconfirmed, that they actually got onto Twain when the water level was down to 6378. In Java, before this happened, there were 439 nests in 2015, 60 nests in 2016, and from 2017 to 2023, there were no nesting gulls on Java. So this pattern continues of, if terrestrial predators, coyotes in particular, access these nesting islands, the gulls eventually abandon those islands. It's not worth that risk, right? There's risk to both chick production, but also to them. It's a long-lived seabird. They're making choices to avoid terrestrial predators that could result in not just losing their chicks, but losing their own lives. And in 2016, what's interesting is the coyotes actually accessed Nedget and swam at least 200 yards to Java. So they're capable of they're not just walking there. They actually had to swim, and so they are capable of making those shorter swims, and so that's a risk. And of course, once they figure out incentive to come back is great. There's an amazing food resource, all the eggs in the world you'd want on these islands. And so once the Nedget islets are accessible to terrestrial predators, there's really nowhere else for the gulls to nest on the island. It is their last refugia from terrestrial predators at Mono Lake. Next slide. So I wanted to provide some context about California gulls. The majority of the Californicus subspecies does still breed around the Great Salt Lake. We heard about other bird species today. Great Salt Lake is just this enormous, the scale of the Great Salt Lake is just orders of magnitude larger than these other saline lakes. Again, the largest breeding population, but there has been no formal census of the entire population at Great Salt Lake, such as is done at Mono Lake for a number of years. Unfortunately, Great Salt Lake has lost up to 70% of its volume in the last 100 years. Climate change, drought, water diversions threaten that ecosystem collapse. That's been well documented in the press. And so there's large concern. I think that the image on the bottom right there is showing efforts here to build a levee to isolate the hypersaline waters from the fresher waters, the less saline waters at Great Salt Lake, to try to maintain habitat for all these species that use this saline water. You can see the bright red briny water to the right there. So Great Salt Lake's imperiled, no doubt about it. And so there's a huge risk that we could lose that if that ecosystem collapses, we could lose the vast majority of the California gull population in the world. Next slide. I won't go too far into this because Nathan's going to present all the data about this, but the South San Francisco Bay population is now a large percentage of the Californicus subspecies breeding population. The population exploded after the Nedget Island colony abandonment in the 1980s at Mono Lake. They're using artificial salt ponds, habitats, and landfills. They're a threat, and Nathan will talk about this, some listed species down there. So they get a bad name is when gulls are around people doing things that are not appreciated for conservation. And that salt pond habitat is at risk because it's being converted, and obviously sea level rise will affect it as well. Next slide. So that brings the idea here that Mono Lake is critical habitat for this species. Even though the population is in decline, it's a protected place. It has a mechanism to maintain water levels. Unlike many of these other places where there's unregulated diversion of water, Mono Lake is one of the better places to manage for this species. And California gull was removed for the California bird species of special concern, which is kind of, think of it from a state level as one level below being listed as threatened and endangered. It's the distant early warning to avoid listing of species. They were removed from that list in the 2008 revision to that list. And the reason they were removed from that list was because there was a Bay Area population that had been established and was rapidly increasing, and that Mono Lake had protections that would, from the state water board to raise the lake levels to protect this species long term. And so that really was the justification to remove this species from the list. And so maintaining water levels at Mono Lake for this species is critical to the long-term population viability in the state of California. And with that, I am done.
Thank you, Ryan. Thank you for that presentation. Our next and last presenter for today is Dr. Nathan Van Schmidt. He is the Director of Regional Strategies at the San Francisco Bay Bird Observatory, where he studies how water management, climate change, and habitat conditions influence waterbird populations and conservation outcomes. His research focuses on California gulls and phalaropes, including how changes at Mono Lake affect bird populations across the Great Basin and San Francisco Bay, and he leads efforts to model phalarope population dynamics across saline lake ecosystems. Thank
Thanks.
you, Nathan, for being here.
Yeah, thanks for inviting me to talk and for that introduction. And thanks, Ryan, for setting a lot of the context here. Yeah, I'm going to be finishing the workshop today by expanding from Mono Lake and talking about how the ecological conditions there have had spillover effects elsewhere in California. Next slide, please. Particularly about the San Francisco estuary. This is the largest estuary on the US West Coast. Over 1 million waterbirds use it each winter as part of the Pacific Flyway, and there are numerous breeding species as well. Over 90% of the tidal marsh in the estuary has been diked and converted to other habitats, starting with the gold rush, which is what's shown here. The black areas are the only remnant historical wetlands. And because of that widespread loss, there is a massive investment in wetland restoration, and I'm going to focus on this highlighted red area today in South Bay. Next slide, please. That is the South Bay Salt Pond Restoration Project, which is currently the largest marsh restoration project on the US West Coast. Throughout this area, the tidal wetlands historically were converted into salt evaporator ponds. So if you go from left to right here on this image, you can see these ponds that are divided by levees that get progressively more and more red, and that's the water being pumped through a series of water control structures where it's evaporated progressively. The salt concentrates, the red ponds here are the saltiest, and then eventually it's harvested off. In 2002, the U.S. Fish and Wildlife Service and California Department of Fish and Wildlife bought most of those ponds and are now restoring about half of them to either tidal wetlands or wildlife ponds rather than salt production ponds. And that not only creates habitat for endangered species like ridge-raised rail, salt marsh harvest mouse, it's also critical natural infrastructure to protect communities from sea level rise. The South Bay here is a very wealthy community, Silicon Valley, but there's also a lot of disadvantaged communities, especially the ones that are nearest to the water here, living in subsided areas that are under severe risk of flooding. So that's all a massive undertaking with a total estimated cost of this project of over $1 billion, and it's going to take several decades to complete in full. Next slide. Because those ponds are hypersaline, it has long had really significant connections with Mono Lake, supporting many of the same species. Phalaropes, for example, have regulatory SEPA and NEQA thresholds that have been set for them that the project needs to maintain their populations at. However, those species have declined severely over the past 2 decades. Crossing those thresholds, they're actually the first major threshold in the project to be crossed. And that has significantly complicated restoration planning. There's ongoing assessment of whether or not these designs need to be adjusted, and if we need to change how we're doing the restoration. And if you could click ahead. There's also a second species to hit the targets, was another saline lake specialist, Bonaparte's gull, which winter in saline lakes and here in South San Francisco Bay salt ponds have also experienced a steady 2-decade-long decline. Next slide, please. Now, obviously, our initial hypothesis for this was that this was caused by a local management decision. In particular, the salinity in a lot of these ponds has been lowered to make them more generally wildlife friendly. So you can see in this graph a general reduction in the extremely hypersaline habitats, which are the yellow colors, which are the over 150 parts per trillion salinity, towards more shifting towards more brackish habitat, which are the bluer colors that get down to like the normal estuary levels of around 30 parts per trillion salinity. And it was really believed initially that's probably the thing that's responsible for causing these saline specialist declines, right? Next slide, please. However, we've been doing multiple studies now for several years, and all are pointing towards local habitat actually improving as the result of this shift. For instance, here we fit statistical models of how changes in pond characteristics related to changes in phalarope counts, and found that the most significant relationship actually was that phalarope abundance was increasing at the pond scale as salinity was decreasing. So even as the overall population was declining, the phalaropes were doing better and better in the ponds that saw these salinity decreases. Next slide, please. And when we did more in-depth studies of the salinity associations and foraging, we saw why. As mentioned in the previous workshop, alkali flies really do best at only slightly hypersaline habitats, really around 50 parts per trillion. And we see that as the ponds decreased from the crazy high salinity of salt production ponds, which were at times like over 150 parts per trillion, they've actually moved more towards that optimal salinity band. We can see that not only in abundance, which is shown on the right, but if you can click ahead, we also see in the foraging rates in the ponds, when we do foraging behavioral studies, the phalaropes are confirmed to be feeding most rapidly and most consistently on the ponds that are in this 50 to 80 parts per trillion low hypersaline range. So all this evidence really points towards, next slide, a rejection of this initial hypothesis. It does not appear to be the result of shifts in habitat conditions in San Francisco Bay because the range of salinities has, if anything, been increasing slightly, at the very least steady at the landscape scale, with more and more of these ponds in this marine to low hypersaline range that they really seem to like. Next slide. So by that process of elimination, we're now suspecting that the problem is not local, but may be the result of declining habitat conditions at other saline lakes, which have been, as you've seen through the other talks here, really well documented across a range of gills. That's very hard to directly test or link, but we have additional evidence as well from eBird and those historic gel surveys that the declines actually appear to have began before even the start of the restoration project, dating back through the 90s as well. So that does seem rather likely. And regardless of all of that, as Ryan mentioned, the ongoing tidal marsh restoration where levees are going to be breached here and those ponds will be converted to mudflats that are going to regrow into vegetated mudflats is eventually going to cause habitat loss for these saline specialist species. So from that perspective, maintaining quality habitat at Mono Lake and other naturally hypersaline water bodies in California is going to be even more important in the future. Next slide, please. Where there's an even clearer link, and the main thing I want to talk about today is California gulls. We just saw this figure of how in 1979, the falling lake elevations connected the main breeding colony of Nedge Island to the mainland and allowed coyotes to access it over a series of years, leading to its abandonment. Next slide, please. And pretty much directly after that initial abandonment and access in 1980, California gulls colonized and started breeding in South San Francisco Bay for the first time. They overwinter off the coast here, but they were never breeding here. We've been censusing these breeding colonies annually for 30 plus years, and during that time, we documented an exponential growth in their population. In the middle of that period of growth, Lake's level was mandated in 1994 to help recover that ecosystem. And as mentioned, because of those two things, the legal protection for the lake and the exponential growth in the San Francisco population, in 2008, the California gull was removed from the state list of the birds of special concern. Next slide. However, that growth here locally has had significant negative local impacts. Shown here in red, you can see that the California gull growth has resulted in abundances that have totally overwhelmed local breeding tern populations by an order of magnitude. Next slide. And unlike the locally native breeding gulls, like Western gulls, which breed off the coast, California gulls are now here within the estuarine habitats within the bay during the breeding season in these breeding colonies. As you can see here, again, with California gulls in red and total gulls in blue, basically all the gulls in the breeding season are California gulls. That leads to unique negative ecological impacts of California gulls here in San Francisco Bay. And I want to emphasize that that's not because California gulls are a problem species in general. As Ryan covered, they're great for a lot of reasons and very interesting and unique birds. It's a problem specific to San Francisco Bay because they don't natively breed in significant numbers here. No gulls do. Uh, Next slide. And because California gulls are pretty voracious nest predators, these massive colonies have significant negative impacts on native nesting water birds that have been documented across a huge range of species that are either declining, and in some cases actively listed by the state and federal government. American avocet, which Blake highlighted as the most rapidly declining shorebird, lose over 60% of their chicks in the region to California gull depredation. California gulls also predate nearly a quarter of blackneck stilts and nearly a third of the Forster's tern chicks. California least tern, a listed species, saw gull control increase their nest success. It more than doubled it, and it increased the number of fledglings per pair fivefold. So huge increases. And for another listed species, Western snowy plover, it has been documented that California gull are the most common nest predator of that species here in South Bay. Conserving each of these species is a major management effort that costs hundreds of thousands of dollars each year. Next slide, please. And just again to drive home how significant these impacts can be, in turn, this graph shows tern chick fledging success on the y-axis and an index that combines distance and abundance of gull predation pressure on the colonies. And you can see that the tern colonies that are closest to the gull colonies that are really large, it drops the tern nest and fledgling success to basically near zero. As a result of that, significant management effort has been done to force the relocation of California gull colonies. One of the largest ones was the breach of an entire major colony at A6. And after that restoration effort, displaced 2,000 or 24,000 breeding gulls, relocated them, and the nearby survival of tern and chick colonies increased a whopping 900%. So huge, huge impacts. Next slide. That management is now an annual activity that we have to do. Every year we have to go out and haze gulls and destroy their nests at key sites throughout Don Edwards National Wildlife Refuge. Shown here is one of those sites. This was a $7 million construction effort to create nesting habitats in the Ravenswood SF2 complex. The west half of the complex was converted into a salt pan for snowy plover nesting. And on the right half here, you can see a set of nesting islands that were constructed for shorebirds and terns. However, California gulls are also continuously now trying to set up nesting colonies on those islands, and every year we have to go out and toss all of those eggs into the water to prevent them from doing that and threatening the nests of these threatened and endangered, or threatened and declining species. Next slide, please. Now, it's pretty difficult to determine conclusively the cause of the population boom. It could be driven by some immigration from Mono Lake, or it could be driven by local reproduction. It may be a bit of both in different times, depending on the conditions in each. One thing that is believed to be a really key factor, though, particularly in allowing the population to get larger than it could naturally to these hugely inflated numbers that can overwhelm the other nesting water birds, is the subsidization of anthropogenic food sources, primarily from landfills. Gulls can be seen foraging in huge flocks on the landfills that ring the bay. Next slide. So around when birds were removed from the state list of conservation concern, falconry programs began on the landfills to try and chase the California gulls away. They've got folks out there every single day driving around in ATVs with falcons, dogs waving, these big flags on spears at the gulls, like remind me sort of Don Quixote chasing away windmills. But the have this big effort across multiple landfills to do this. These programs were very successful within just 5 years, since around 2012. At the active landfills, daily visits from gulls dropped from over 1,000 to fewer than 100. Now, we don't have perfect data on these landfills. They are privately owned, but we know that these efforts are happening on at least 4 landfills. And based on that and the cost data that they have shared with us, this is around $800,000 each year for the management of this ecological problem, with a potential upper limit of around 2 million if all 10 of those landfills do have programs. Next slide. So while those hazing efforts have been a management success story, it is not really the end of the story, because while we've been trying to deal with California gulls as a problem in the Bay Area for the past few decades, they've been in trouble themselves elsewhere. Concurrent with the removal from the state list and the abatement and hazing efforts beginning, we saw this leveling off. We see a really big drop just after that, which is that big relocation. But then the birds did not really move elsewhere. They popped back up in the early 2010s as they began reforming those nesting colonies. And then in 2021, they were added to the federal list of birds of special concern. And now, as mentioned, in 2024, California gulls have reached record low productivity at Mono Lake, near total breeding failure, continuing a long decline documented in the previous talk. As well, they are now declining pretty consistently across the in San Francisco Bay as well. Next slide. So the overall takeaway I want to end with here is that we're really facing a conservation conundrum here. We now have our own ecological needs in San Francisco Bay that we are trying to restore conditions to. We have these low-lying, subsided, disadvantaged communities that are at extreme risk from sea level rise that we need to build tidal marsh to protect. We have a lot of other native water birds that are already trying to make use of a smaller and shrinking number of habitats. As a result of that tidal marsh restoration, we're losing pond habitats. And the connections between Mono Lake and these other stroke lane saline lake ecosystems are making those decisions much more complicated. We now have 60% of the total California gull population. If land bridge issues continue and we get a total abandonment of Mono Lake, it could be nearly 100%. And with, 40,000-ish birds here locally, we're now nearly double Mono Lake's population of what was the primary native population in California previously. And in addition, we're at about 10% of the total global population. The species has been federally listed as of conservation concern, and neither of the conditions that the state made for removing gulls from their list of species of conservation concern is now met. We still have unrecovered Mono Lake water levels, and the exponential growth has ended here in San Francisco Bay. And we are really just facing this as kind of a wicked problem to address some mutually incompatible conservation needs. We're not really sure how to be managing this, if we should continue treating these birds as a problem, if they're in crisis elsewhere, and how to balance out those needs. So in order to do that, I think having good native habitat that is solid would certainly help that situation, so that we're not relying on habitat that they're not native to help support these species. Next slide. And with that, I'm going to conclude. I want to give a huge thanks to everyone that has made this research possible. The core gull and phalarope monitoring data that we collect is a big effort by community volunteers, dozens and dozens over the years, and we're very grateful for that. As well, Amy Parsons, the lead biologist that organizes this work, is absolutely indispensable contributor to that effort. And all the many other researchers that have worked on these efforts over the decades. I cited them here. And of course, our funders. So That's it. And I am also happy to answer any questions over email if folks do want to ping me. I did not put it up here, but I believe it is on the workshop webpage. Thank you.
Thank you, Nathan. The conservation challenges in San Francisco are certainly an interesting element to this larger, the larger avian challenges. At this time, we are open for Q&A. Questions could be about Ryan or Nathan's talk during this second half, which was, more focused on the California gulls and some of those conservation challenges, both at Mono Lake or the San Francisco Bay, or any of our presenters in the first half. Yes, Ryan Carl.
Sorry, yeah, I don't think I could write in the chat, but I wanted to ask Ryan Burnett if you could expand on the relationship between the gull productivity and the freshwater inputs and the meramixis. That seems like a complicated subject of if you put more water in, it's causing gull productivity to decrease, but what are your thoughts on that?
Yeah, thanks, Ryan, for that. Yeah, to steal from Nathan, I think it's a bit of a wicked problem, rock and a hard place for the gulls at Mono Lake. I would just say first and foremost, without predator-free nesting islands, doesn't matter what the productivity of the lake is, they're not capable of breeding there. And so that has to be first and foremost. The challenge now is that we're in a period of climate change or, local conditions that we've been having in the Sierra for the last 25 years where we're getting boom or bust years. And, these predictions are this is just going to continue where we go through these cycles of extreme drought and then some years where we have just unprecedented precipitation. So we had years like 2017 and 2023 where we got huge snowpacks, and then we also went through a 6-year historic drought. And so what's happening is Mono Lake is getting water into it generally only in the boom years, and so it's being brought down. Say, salinity increases, and then it's getting a large influx of fresh water, and that is just increasing the probabilities of these meromictic conditions, these lack of mixing of the lake. And so I think probably Milak and Jellison talked about this in their presentation. If the lake has more salinity, the probabilities of stratification are greater. And then now we're throwing on top of that climate change, which is resulting in these boom or bust cycles of we dry the lake out, we lose water levels when it's a drought, and then we throw in a ton of water or a large amount of water in 1 year. And that just results in this stratification. And that stratification just depresses lake productivity and is the strongest influence on the gulls' productivity at Mono Lake. There's no doubt about it. And it's a relationship with, the food, the prey availability on the lake. We haven't been able to tie those as closely to the actual abundance of the species. So right now, the best predictor we had is that increase in lake level the year before, or freshwater input, which is really just an indicator of stratification of the lake. And so you see those dips every year or every few years that we saw early in the study, maybe once a decade where it would happen for a year or two. Now we're getting, in the last 10 or 12 years, we've had meromictic conditions more often than not. And so it seems like the lake is more susceptible to entering meromictic conditions, and then they're persisting longer. And so we don't see a 1 or 2 year dip in gull productivity. We're seeing 3-4 year dips in gull productivity. And so this habitual low productivity seems to be a major driver of the decline in the population at Mono Lake.
Thank you, Ryan. Other questions from our group? Panelists or attendees? Ryan Burnett?
And I'm not going to ask a question of myself. So Nathan, what can you talk more about the long-term plan for gull hazing? Is there now a pressure in the Bay because they've been federally listed as a species of concern and obviously this is wildlife refuge, federal wildlife refuge land, so they need to consider that. What is this kind of wicked problem, and how is the federal government kind of guiding you guys in these efforts? Is the hazing going to continue? Is there a population level at which they're shooting for? Or yeah, just talk more about that.
Yeah, really an open question right now. It was the 2024 conditions at Mona Lake with the pretty near complete collapse of breeding productivity that really caught the headlines here of like, wow, maybe we should be starting to reconsider exactly how aggressively we're hazing these birds. The hazing at present, I think, is limited enough that we're not that concerned that it is necessarily going to be really damaging the populations in mass. Compared to the bigger efforts with like the restoration of A6, where it was like 20,000 birds being displaced from a breeding colony. That was a much more significant effort. I think if that came up again right now, we might look at how we're doing that and whether we want to make that decision. But we are continuing for the present to haze them just because they are doing, well enough here that the other species of concerns like avocet stilts that have been continuously declining for the past 2 decades locally are really on balance there. But we are really just trying to figure out what we should do. It's very much an active subject of discussion, and the ability to bandwidth because there have been various budget cuts to the wildlife refuges here as well. It's a slower process than we probably like it to be, because just the staff bandwidth to try to figure these items out is significant. Um, yeah.
Great question. Thank you, Nathan. Other questions from the group or even closing remarks from any of our panelists today? Brian Carl.
I just wanted to add, since we did not have the chance to hear from Sean Boyd about eared grebes, that I'm not exactly sure what Sean would have said, but I just want to emphasize that the themes that I talked about with phalaropes are very similar for grebes, where they are very concentrated, perhaps even more so at Great Salt Lake and Mono Lake than the phalaropes are, and of course undergoing the same habitat issues as the phalaropes. So and also that we get, a million eared grebes at Mono Lake sometimes, and that in terms of avian biomass at Mono Lake, they are far and away the most common species and something that we really need to be thinking about too. So I would encourage everybody to watch Sean's recorded talk and just want to emphasize that everything I said about phalaropes and how their habitat is threatened goes for eared grebes the same.
Thank you, Ryan. And we are going to work with Sean if we can do a recorded presentation, that would be ideal. Otherwise, I think we're also looking at him maybe adding a little more content to his slides. His slideshow presentation will be posted along with the other presentations by end of day tomorrow. And you can go online now and take a look at his background, his research, and a summary of his presentation to at least get a sense of what he would have presented today. Nathan.
I'll just add on that note that I didn't talk about eared grebes, but the situation is similar in San Francisco Bay, with eared grebes also being a major connection here. They haven't hit management triggers here, but the situation is a little more complicated since they do appear to forage more on the higher end of the hypersalinity spectrum. So it does seem more likely that it might be a local condition issue there. But there are, especially, I think, probably the species that's most likely to disappear from the Bay Area as these restoration projects continue. They've already pretty much been lost from the local restoration project ponds because they do use more of those super hypersaline habitats where it's primarily brine shrimp.
Hmm. We have a couple questions in our Q&A. One of them is, many of these presentations have discussed myrmexis and stratification on ecosystems. Is there research on Mono Lake on the conditions that lead to and sustain myrmexis? For that question, I would like to mention that Dr. John Milak and Dr. Dave Herbst gave a presentation that went into this research. That is available on the Mono Lake Basin website from June 4th, but Dr. John Milak's research and Dr. Dave Herbst's research certainly touches on that. Would any speakers here like to speak more to it? I know Ryan Burnett, you kind of mentioned it, but I know that it has been all of you have touched on it or it's been part of your research simply because it's been the trend since the 80s.
Yeah, I would just reiterate that, meromixis is caused by fresh water that is heavier coming in and sitting on top of the lake, and then the salt water can't get up underneath it and mix that water. And so lake mixing is really important for, just like our ocean upwelling, of bringing nutrients and cycling nutrients in a lake. And so that freshwater input really is the driver. But the drivers are the levels of salinity in the lake. So that difference, that chemocline difference between saltwater and freshwater, is driving that stratification in the lake. And then the factors that influence its persistence are, I think, more complicated and related to water temperatures and wind patterns on the lake, and also the amount and depth of that kind of stratification layer of dense water on top. And so that's where I would go listen to Dr. Milak's work. He's an expert in this and can talk more. But it's that's an important area of research, is understanding the sensitivity of Mono Lake to stratification is a really important factor going forward, and understanding that better, critical to managing the lake.
I think my follow-up question with that is, do we have a sense in the research what would help buffer Mono Lake from these prolonged and periodic stratifications? And I can put that out to anyone, or Ryan, I see you have your hand up. Ryan Caro.
I'll just echo what I learned from the first workshop and what Milak and Herbst covered. I do remember Milak, the limnologist, talking about how this at the current levels of the lake that we've been experiencing, the lake is smaller and saltier. So when you put a big influx of fresh water in, you're more likely to get this stratification. And he said in his presentation, if you get the lake up to a higher level and it's generally fresher, that he expected to see less periods of meromixis and stratification occurring. So it does have a influence there. And then I also wanted to mention that in Dave Herbst's talk, he was talking about how the shallow near shore zones with the tufa rocks that are really important for fly production are actually pretty discoupled from this meromixis problem. And so when you're seeing the impacts of the productivity on meromixis, that you're seeing the impacting the shrimp that are out in the kind of pelagic zone of the lake, but actually on the fringes of the lake, when the lake is fresher, it's not affecting the flies as much as it is the shrimp. So that is important for the bird species you're talking about, where you have grebes and gulls that eat a lot of shrimp, and you have phalaropes that are eating a lot of flies. Everybody eats flies, but the grebes and the gulls rely more on the shrimp. And they're the ones that we're seeing these correlations between the meromixis and the productivity and their biology of the birds. Whereas Dave Herbst was saying basically the flies, it's a discoupled, the littoral shallow zone is not being affected by it as much as the middle of the lake.
Yeah, I would just add, and Dr. Milak has talked to me about this, that meromixis is not a binary event at Mono Lake. There's levels of it, and so there's always some part of the lake that's always mixing, whether that's 6 inches deep on the shoreline or that's 2 feet deep in the middle. But that level, and so it's levels of meromixis that matter. And so when you have a deep stratification, the effects, you saw the dips in my data, those tend to get deep, deeper declines in productivity in the lake. And so understanding that and how it breaks up slowly. So there's levels of meromixis. So there's potential to reduce meromictic, not necessarily times you get it, but how intense the meromixis condition is and how long it lasts, I think are areas that we need to understand better to manage the lake and ensure resilience for these populations of species.
Thank you for helping to tie workshop 1 in with workshop 2 and carrying over those concepts because they're really foundational. Thank you so much. Let's see, we've got another question. Would a predator removal program on Nedget Island be helpful and is it feasible?
Yeah, so as best we know, Nedget doesn't have freshwater sources on it. There are no permanent resident predator populations on Nedget. It's more the episodic access to the island that's been the problem. And the island for large stretches of the last 30 years has been predator free as far as we understand. And the gulls have just chose not to return. And so those go into factors of colonial water birds and making decisions about net, like you want to be the first one to go over there. Like, why is nobody going over there? The birds that are nesting at Mono Lake now do not have memory of those coyote events in the late 80s. You know, they only lived 20 or so years. But why they won't recolonize that? There have been small numbers of gulls going to Nedget, but they just have chosen to nest on, you know, they want to nest colonially in tight groups for you know, safety in numbers and all that. And so they have just not returned. So it's possible if lake levels were returned to an area, you know, we wouldn't want to, we can do some con-specific attraction with, like, they've done things like Atlantic puffins are a good example of this, where they actually put decoys out there, make calls, and then the birds return to nest there. So that's a possibility down the road. The risk of doing that now is that Nedget is most vulnerable to land bridging and the coyotes getting back out there. So do we want to attract birds back to a place where there's no guarantee at these current lake levels that they could successfully nest? And so I think once lake levels return to, you know, something closer to the mandated level, then that's a real possibility, because some of these Nedget islets actually will go underwater at that point. So there will be a need to pull gulls back to their historic grounds. But you don't want to do that until you have assurances that that land bridge isn't going to reconnect and you're not going to have this huge disruption to the population that we believe led to the colonization of the Bay Area, where they just abandoned and said, I'm not going back there, I'm staying in the Bay. So yeah, I think that's down the road, but there has been efforts to put up an electric fence as a last resort in the 2016 period when the lake levels got low again. So there was an electric fence put up to keep the coyotes out that seemed to work pretty well. That fence was being proposed to be reactivated here in 2022 when the lake levels got low again, and then 2023 water levels brought the lake up high enough that was shelved for later periods. So there have been efforts. There was a blasting of the channel by Army Corps, I think, back in the 80s to try to create a barrier for Nedget Island. So the easiest, simplest solution is to raise the lake level for the gulls, is to raise the lake levels higher, that ensure that Nedget is a safe, predator-free environment.
Thank you. I want to draw attention to a couple questions that have been answered in the chat. One was, are there any efforts to save Great Salt Lake? Blake went ahead and answered. He said, I encourage you and others to explore the environmental conservation efforts at Great Salt Lake starting here. And he dropped a link in that connects to the Great Salt Lake, Utah government site that's documenting those conservation efforts. And then in response to a question about Miromix's stratification and the research on that, the link to the recording for workshop 1 is in the chat. And of course, we can look at that on the website as well. And any other further questions or thoughts we want to share before we wrap today? Well, if I can have the last slide put back up. Thank you. And I want to give a very special thanks to our speakers today for their very thoughtful and informative presentations. I was chatting with them earlier today, and I'm like, this is just a really skilled group of presenters. The slides were informative. It was fun to follow, a lot of really interesting information, and a lot of real serious challenges out there they're trying to tackle. So I appreciate your time today. Again, we're so sorry that Sean couldn't be here, but we'll work to get that information out to you. As a reminder, the recording for today's workshop, as well as the presentations shared, will be available on our Mono Lake Basin website by end of day tomorrow. And then if you have additional questions, if questions come up in the middle of tonight, or we were unable to get to your question, please submit your written question to the email provided on the screen by noon on July 2nd. So that's monolake@waterboards.ca.gov. And again, we will review all of them and pass them along and answer them if we can. So thank you again to our speakers. Thank you all for attending. We're going to wrap just a little early today. Again, we really appreciate you all being here today. Thanks again.